All right, welcome to section 4.4. Thanks for joining. Throughout chapter 4, what we've covered so far is essentially the development of the unit circle, and talked a little bit about like those coordinates, how you have to memorize. When we're talking about trig functions of any angle, let theta be an angle in standard position with xy, a point on the terminal side of theta, and r being equal to the square root of x squared plus y squared, which cannot be equal to 0. Essentially just saying that now if we don't have a unit, a single unit as our radius, the radius can be given by the square root of x squared plus y squared, essentially just doing the Pythagorean theorem there. And that can't be equal to 0, otherwise we don't really have like a circle idea. So if that is the case, then the sine is equal to y over r. In the unit circle, we said that the sine is just y, because the unit radius was 1. So here we're saying that sine is going to be y over r, cosine is going to be x over r, and tangent is still going to be y over x, because the over r's, if I were to do y over r over x over r, would cancel. Now, if you were like thinking about a triangle, and that's what we're going to be doing, you're going to see sine is opposite over hypotenuse, which is the same as just the y-axis over the radius. Cosecant, secant, and cotangent are the reciprocals. So this is going to be r over y, r over x, and x over y. Again, not really a lot that's new there. You could still think of this as opposite over hypotenuse, just keeping in mind that with the triangles that we are going to be drawing, the opposite side is the same as the y, the height. So instead of values of theta that we've memorized, those things from the unit circle, what we're going to do is talk about those things that we haven't. So for instance, if we consider the angle that's formed with the segment 0, 0, and negative 5, 12. And I were to say, what are the 6 trig functions of this angle? So if I'm looking at this, the first thing we're going to do is draw a sketch of it. So we have 0, 0, and negative 5, 12. Negative 5, 12 puts me in the second quadrant. So, you know, I'm somewhere like here. What I'm going to do is always draw a triangle that falls into this sort of bow tie shape, and we'll talk about that in the next slide. But this is part of my bow tie of triangles. So this is the triangle I'm going to draw, and it's perpendicular to the x-axis. With that in mind, if this is the point negative 5, 12, that tells me that the height is 12. The bottom part, the x-axis, is going to be negative 5, which means that my hypotenuse is going to be 13. This is a 5, 12, 13. So now, if I'm talking about this angle, I would say the sine of the angle. Sine is opposite over hypotenuse, or the y portion over the r portion. So 12 over 13. That's a terrible over, 12 over 13. And just to do it right away, the cosecant is the reciprocal, 13 over 12. Cosine, the cosine is adjacent over hypotenuse, so negative 5 13ths. And secant again is the reciprocal of that, so negative 13 fifths. And last, tangent. If you're looking at this triangle, tangent is opposite over adjacent, so negative 12 fifths. And cotangent, the reciprocal of that, so negative 5 twelfths. That's all we're doing here. We don't do that with the unit circle because we want to have some things that we can use that are quick references, but in this case, you know, this wasn't something that we memorized, so we just have to draw this little triangle and answer some questions on it. So now we're going to skip this slide. We'll do that in the examples. Now here, in section 4.2, we talked about sort of that whole idea of all students take calculus. You know, everything's positive here, sine is positive here, tangent is positive here, and cosine is positive here. And what you're going to be doing is sort of thinking about it however you sort of need to, but keeping in mind that when we're dealing with triangle or angles that are not on the unit circle, you are always drawing one of these right triangles. So you've got 4 different options of right triangles. No triangle that you're going to draw is going to be one that comes up here and touches that y-axis. So it's always going to be one of these ones that forms this bow tie, not one of the ones that form that hourglass type of shape. That's going to be sort of the most important thing, because what you're going to have to pay attention to is what quadrant you are drawing these triangles in. Because in different quadrants, sine, tangents, cosines, they change signs. And that's what you're going to have to pay attention to in the question. So for instance, if I have a question where the sine is positive and cosine is negative, I know I'm working in quadrant 2 and thus have to draw this triangle, because that is the only time in which sine will be positive and cosine will be negative. If I know tangent is negative and cosine is positive, tangent is only negative here. And if cosine is also positive, I know I'm in the 4th quadrant, which means I must draw this triangle. All right, again, I would make sure that you go see some examples of that. So then the next thing and the last thing we're going to talk about here in the examples is just what the idea of a reference angle is. So a reference angle, what a reference angle is by definition is the acute angle, acute meaning that it's smaller than 90 degrees, formed by the terminal side, terminal side, and the x-axis. And you've sort of already seen this, but I'll go back and talk about it at the end. We'll call a reference angle theta prime, that prime noting that it's not actually the angle, it's the angle that we're referencing instead. And just to give yourself an idea of what this looks like, if we're talking about this angle, that's a terrible circle. If we're talking about this angle, that's also a terrible circle, but it's sufficient. And I said, what is the sine, cosine, tangent of it? Well, the problem is I can't draw a right triangle using this angle. But what I can do is use the reference angle over here and then use this right triangle. So this is my reference angle. Because having the same terminal side is going to mean that they're going to have the same sine, cosine, tangent, all those 6 trig functions, while technically being a different angle. We already looked at this in that example that I did do. You know, if I were talking about this being the angle, that doesn't make sense, because I said back in chapter 4.1 that angles are going to start on the positive x-axis. So when I drew this triangle, and hopefully most of you didn't really question where I came up with this, but this is actually the reference angle. The angle that we would be talking about would be something like this angle. All right, so we'll deal with a little bit in the examples video as well, how to come up with what an actual reference angle is, the actual value of the reference angle, as well as going through and drawing those triangles. I really recommend going and watching that, just getting a little bit of experience with it before you jump into that homework, because it could be a little bit confusing, especially if you're not paying attention to the quadrant that you need to be drawing those in. Otherwise, jot down any questions and be prepared to ask them.